moving on. Now, today we have Dr. Peter Fath, CEO of RCT Solutions, who was also instrumental in designing and setting up the Kalyon factory in Turkey. Today, Peter will present solar manufacturing cost analysis along the silicon value chain. Welcome to TaiyangNews, Peter. The floor is yours.
Thank you so much for the opportunity to talk to you today about the fully integration and the cost over the full value chain. So now I try to open my screen. So hopefully it can be seen.
Just go in the presentation mode.
Yes. Is it working now?
Yes.
Okay. So I'm Peter. I'm the CEO of RCT Solutions and also the technical advisor of Kalyon PV in Turkey. So quickly, I'm in RCT Solutions. We are belonging to RCT Group. RCT Solutions is primarily focusing, supporting people globally in setting up integrated solar factories. So currently we are executing 5 gigawatt scale factory projects globally. So whenever you want to set up a solar factory, always welcome to come to us. And then we have a sister company, RCT Power, which is making a utility scale battery, residential battery and inverter. And we are shipped last year 3 gigawatt hours of batteries. Now, what is motivating us to analyze very accurately about production capacities and how we want to move forward in setting up multi-gigawatt of production facility is a huge demand globally on solar products. And as we learned from previous speeches, that mostly currently we are concentrated in China as a dominating manufacturer. We have to diversify our manufacturing base globally to enable this huge demand in modules in a terawatt annual production capacity. And that is something which is an ongoing process. We can say currently, if I look at our customer base and other announcements, I mean, we can say globally, we have about 70 gigawatt or up to 100 gigawatt production capacity, which will happen outside Asia, including India. So that means the global society is taking this duty now as serious. So we have to share and put this demand, a huge demand on various countries' shoulders. So now how to do? That is the question, how we should do it. If we want to set up a wider manufacturing base outside China. So now let us have a look. So I will talk first about global manufacturing and integrated factories. Then I will show 2 case studies, and then we will compare the cost, which cost we can reach if we will move outside China. And I will come to a conclusion. So now, in the past, always in this sector, I'm in this sector 35 years, we have seen some crisis. Crisis always happened when the supply chain, the value chain was not balanced. We had crisis in 2004, 2007, 2011, where always the value chain was not balanced. That means we increased huge capacities on module and cell, but the downstream, so the upstream was not following. So we were lacking of polysilicon. We were lacking of glass. And that is something which shouldn't happen anymore. And how we can do it, I want to show you in the next slide. First of all, we can go into a vertical integration. That means if you are setting up a multi-gigawatt type of production unit, and especially outside China, where you don't have this vast supply chain in wafers, in cell, in modules, and you can change and you can purchase everything easily, then you should look at the fully integrated fabrication. That means you should include ingot, wafer, cell, and module into your factory project. And we call it integration 2.0. And then the question would be, if you are in this 2, 3, 4 gigawatt type of scale, and as soon as you're moving forward into a 10 gigawatt plus of scale of fabrication, we also have to consider to include polysilicon and metallurgical silicon production into your portfolio. I not necessarily say you have to make all at one place. I not necessarily say you have to invest yourself. It always can come that you are making joint ventures, you are signing long-term offtake agreements over the full value chain. But I strongly can tell you, you have to control your full supply chain, vertical supply chain, and we call it integration 3.0. This you have to do if you're going into a 10 gigawatt type of project. So please secure your full value chain by different means. If you have a good cost location, which can be cost effective for the whole value chain, then please, you can even consider it to put it at one location. And then, of course, it's not ending with the vertical integration. You also have to go into raw material, key cost contributing raw materials, like glass, like encapsulation, like aluminum frame, like crucible, like paste. So that also how you have to consider when you're going to this 10 plus, 5 plus, 10 plus gigawatt scale. You also have to control your key raw material and key consumables to always balance your supply chain. Good. And this we call 3.0. Now, what are the benefits if you go into integration 3.0? That has a lot of benefits. First of all, you can control your quality over the full value chain. And of course, what if it's on one location, then you can save packaging and shipment as well. And when you see innovations like we learned before from Longi and other companies, you want to upgrade your production line into a new technology. I mean, then it's easy for you because you can make the accurate wafer, which is required for a new IBC N-type technology. You just make it, you cut it in the shape, in the size, in the thickness, whatever you need. And you can make process optimization or process upgrade or product upgrade very fast and easily. And then, of course, since you control the full value chain, it's then much more easier to reduce your cost because you can have more recycling on this part. You can cut at the accurate level what your automation is suitable to do. And then you can easily reduce your cost as well. And then, of course, sustainability, which is a big issue as well. You can, if you have your supply chain under your control, you can make a very sustainable factory, recycling water pass from the cell factory to the wafer factory. You can recycle polysilicon very effectively. And of course, also from the CO2 carbon footprint will be very much more to be optimized into a CO2 carbon neutral type of fabrication. So I just want to say there are a lot of advantages if you go into a full integration. Now coming to cases. Then you say, oh, Peter, everything sounds good. And should we do it? And first, we can clearly see big players like Longi, JS, or Jinko, they're already in integration 2.0. They have ingot, wafer, cell, module factories in their company portfolio. So that means the dominating strong players already are in integration 2.0. They have ingot, wafer, cell module already into it. So that shows it seems to be workable. It seems to be good. Now, the question would be, can we do it outside China? Do we have the know-how? Do we have the capability to make such gigawatt fully integrated factories? And I just want to show you two cases. One case is a Kalyon PV factory in Turkey, in Ankara, which is a fully integrated factory. This factory, which is running at full capacity, has ingot, wafer, cell, module under one roof. And currently it's a 1.2 gigawatt factory, but from mid-March next year, it's a 2.1 gigawatt factory capacity, including P-type wafers, mono-PERC technology, bifacial modules, and it's also connected to a 1.3 gigawatt power plant. So that means, showing this example, it means that we have the capability to prepare such type of integrated factories outside Asia, outside China. It's possible, and it's demonstrated. And you see on this photo, this big factory, it's 240,000 square meter land plot and 100,000 square meter of production area. You see on this drone photo, ingot, wafer, cell, module factory included. It also includes a training academy because there are 2,000 people working in this factory. So you have to train your engineers because you might not find experienced people outside China so easily. And of course, you have to continue to improve your product and product portfolio. And then there's an R&D center included at our Kalyon PV factory. So that is one strong example. And I think now it's one of the largest or the largest Western solar factory what we have. And here you can see also the 1.3 gigawatt power plant associated. And also how fast it can be done. This factory was, and I have been the project director of this factory, was accomplished within 12 months time period. So that means we don't have to wait 1, 2, 3 years to enable a gigawatt factory. It can be done in a very short time period if you have a strong company like Kalyon, who is a strong construction company. Good, then there is a second case on integration 3.0. That is a factor which is currently in the preparation in India by the group SSE group in Andhra Pradesh. And that is a fully integrated metallurgical silicon, polysilicon, ingot, wafer, cell, module, and glass factory included on one land plot. So we have 38,000 tons of metallurgical silicon, 30,000 tons of polysilicon, 15 gigawatt of ingot and wafer, 10 gigawatt of cell, 10 gigawatt of module, and 2,000 tons of glass per day in the final expansion phase. So that shows you, and it's on a 4 square kilometer of land plot in Andhra Pradesh. So that also demonstrates that people like SSE, like Reliance, like Adani, big Indian groups are working at this fully integrated fabrication. So that seems to be the right decision. Good, now coming to the cost. Everything is not working when the costs are not there. So here you see the bunch of technologies which we have, in which we can select on metallurgical silicon, polysilicon, ingot technology, wafer technology, cell technology, module technology. And the previous speaker from Longi already gave some summary of the technologies which we are in discussion and the execution. So as we learned, that currently TOPCon technology is the most new technology which will materialize and already materializing. So we concentrated our analysis on a full value chain, metallurgical silicon, hydrochlorinated polysilicon, diamond wire cut, ingot, mono ingot growing, diamond wire sewing, cell production in TOPCon, and then half cut glass cell. So our cost case study is a pure cost study. So we have not included any profit over the full value chain. So it's a pure naked cost analysis, because if you start to include profit, then we are confused. So that we analyze for 5 gigawatts of case, including all the supply chain steps, including glass. And what was the outcome? So before I come into the outcome, I also want to say about the technology which you have to discuss. We have learned before, please, technology is just a supporting agent to enable a product portfolio and satisfy your customer. If you are in this premium class, you can select about IBC. If you are in utility scale, you should look at large scale modules, including TOPCon technology or PERC technology. So all these tags to select the right technology for a PV factory, you have to look accurately before you make your decision on the technology. Target market, product portfolio, what is your factory size? What is the time to market expectation? What is your investor's risk profile? Do you want to have an upgradable factory for future new technology to be included? Then access to people, access to technology, availability of equipment, availability of material, all these aspects have to be considered before you start to plan your factory. So don't look primarily at the beginning, what is a technology? First look at this analysis and then select your technology. And we have the choice, and you will find your good choice. But now, as we decided, we have selected now a 5 gigawatt case study on TOPCon, and we have analyzed it for different cost locations. And I will come to it in this slide. So here you see our result of our analysis. So we have compared India, China, EU on the low labor cost and low energy cost location, USA on an average cost location, and Europe on a high energy and high labor cost location. And that is a pure cost analysis on a top 5 gigawatt TOPCon factory, fully integrated. And here you see the result. So if you look at India, it will be in the range of 19.9 cents per watt peak, as compared to 18.9 cents ex-work cost in China. And then even Europe, in a low cost condition, we can run at 21.7. USA will be a little bit more expensive as compared to European higher labor cost and higher energy cost kind of location. But if you look at the Accord conclusion is that regardless where we are setting up our factory, we can be in this 10 to 15% cost corridor. That means if we have the size, if we have the supply chain under control, we can make a cost-effective, competitive factories any place. Any place means at any industrial big economic zone globally. So that means this starting assumption, what I did, can we put our demand of modules on more shoulders globally? A clear saying is for me from the cost analysis, yes, it can be done.
Sorry,
so keep that in mind.
We need to wrap up in 1 minute, please.
Yes. So that is a little bit the summary of how it is going in labor cost, depreciation, and material. We have now different subsidy schemes given by government to initiate manufacturing in Europe, in USA, in China, and in Turkey and India. You can learn about it when you look at the slides. So just as a conclusion, we are able to set up fully integrated factories globally. Cost is in a competitive edge. Wherever we put the factory, when we do our homework, it has to come into a size. So I just want to, as a conclusion, be brave. If you want to invest in solar factory fabrication, just do it. The market is huge. Thank you very much.
That was a very, very interesting presentation, Peter. There's one question though. So, of course, it's quite nice to have everything in-house, but what is the degree of integration that starts to make sense, and what is the minimum size that you should start with?
Yes. If you look at integration of cell and module, then you should be at the 3 gigawatt type of size. If you look into ingot and wafer and cell and module, then you should be at the 5 gigawatt size. If you look into an integration of polysilicon and metallurgical silicon and glass factory, you should be at the final target of a 10 gigawatt size. Because then you are at the 35,000 tons of polysilicon, which is a minimum size you should do to have a cost-effective polysilicon fabrication. So we can say 3 gigawatt, 5 gigawatt, 10 gigawatt.
Wonderful. That's really concrete numbers. Thank you so much for being here. And I would really request you if you could please be on the chat. There are a lot of questions. Your presentation has started. So if you could please answer those there, that would be nice. Thank you.
My pleasure.